Welcome back, guys. This is question 3.1 of chapter number 3, which is related to the random variables and probability distribution. Okay, so in this first part of our question, what we are going to do, let us see. So classify the following random variables as discrete or continuous. Okay, so as you may have known that there are basically two types of the random variables. The first type is the discrete random variables as listed here, and the second type is continuous random variables. So we have to identify that which of the following are the discrete and continuous one. Okay, so let us first see the first part here, and that is X, the number of automobile accidents per year in Virginia. Okay, so here we can very clearly see that in order to see the number of accidents in Virginia per year, so if we have this line and here we have to see these are the months, okay, and these are the accidents on y-axis. So we can very clearly see that either those would be 0, 1, 2, 3, 4, 5 or so on. Okay, so these all of these has been taking a discrete values. Okay, these are basically showing us the number of accidents which are basically either this is, let me have here the 1, here this is, let me have here this is 2. Okay, this is again in the second month we have here 2 accidents and so on. Okay, so this is what this is all about, the discrete values, and accidents can have a whole number. I mean, these can be 1, 2, 3 up to infinity, okay, or 1000 and so on, and it cannot be 1.5, 0.5 and so on. So this is basically the discrete random variable. Okay, this can be represented by this discrete valued graphs, and therefore this X is what? This is the discrete. Okay, so I have been writing them here with this DIS. Similarly, in second part, Y, the length of time to play 18 holes of golf. Okay, so the length of time here can range from any value to infinity. Okay, so it can either be 1.77 seconds. Okay, it can also be 20 seconds. Okay, it can be 1.7859 seconds or 200.259 seconds. I mean, the time can range from 0 to any value, so this all values would be continuous. Okay, you cannot discriminate between these two values. Okay, so therefore these will be so close with each other that you cannot distinguish between them, so those will follow a curve like this one. So therefore the second one, or Y here, will be what? This would be the continuous random variable. Okay, so I hope you have understood my point, that wherever you can distinguish between the values, here you will see that this is a discrete, and wherever you cannot distinguish between the consecutive values, this will be the continuous, okay, or the continuous random variable. The third one here is the amount of milk produced yearly by a particular cow. Here we can also see that we cannot distinguish between the values because it can either be 1.7 kgs or liters. Okay, it can be 10.85 liters. Okay, it can also be 21.5897 up to infinity. Okay, so these are all the values which the amount of milk can be composed of. So therefore this value is again what? This is again the continuous random variable. Okay, so you have understood the essence behind this question. So similarly, and the number of eggs laid each month by hand, so therefore it cannot, we can also see here that the number of eggs cannot contain 1.5, 1.6 or all the numbers which are composed of this decimal value. So these would be 1, 10, 2, 5. So therefore this is again the discrete random variable. Okay, the number of building permits issued each month in a certain city. So the number of permits will also be composed of the discrete values. It cannot be 1.5, 1.7, 2.7, 2.8, 3.8 and all the values which composed of the decimal points, but it will be a value composed of the whole number. So therefore this is again the discrete value, okay, as we have mentioned before. Similarly, Q, the weight of grain produced per acre, okay. Again, the number or the weight of a grain produced per acre can range from 1.7, 0.0, 0.111, 0.789 and it can contain any value. You can see that the weight can be composed of any value. These will range from 0 up to infinity, and here all the values cannot be distinguishable. So therefore this is again a continuous random variable, okay. So you have seen here the answers. This is the answer of the first, this is the second one, this is for M, this is for N, this is for P, okay, and this is for the Q1, okay. So that's it for today, in which we have seen the difference between the continuous and discrete random variables, how to see that whether a certain random variable is continuous or discrete, okay. So that's it for today, and I will see you with some more interesting stuff like this one in our upcoming video. So see you soon. Welcome back, guys. This is question 3.2 of chapter 3. And the statement of it is, an overseas shipment of 5 foreign automobiles contain 2 that have slight paint blemishes, okay. So if an agency receives 3 of these automobiles at random, okay, so basically the agency has been receiving 3 automobiles which are selected in random, okay, and of these automobiles list the elements of the sample space using the letters B and N for blemished and non-blemished, okay. So B for the blemished, okay, and N for the non-blemished. So respectively, then to each sample point assign a value x of the random variable x representing the number of automobiles with paint blemishes purchased by the agency, okay. So now here we have a random variable x, which is what? Which is a random variable and which describes the number of blemished automobiles, okay. So now here we have to find the number x which represents x, okay. So here we have to write them as well, okay. So let me write them here as well. So here first we will write here the sample space or the combinations, total combinations we will have, and here let me write the value of x. So what is x? The number of blemished, okay. So now here the first element here would be what? Let me have all 3 non-blemished, so I will have here N, okay, as we have 3 automobiles. So therefore if in random we can have here 3 automobiles which are non-blemished, so here the value of x would be 0, okay, because no B is available here. Similarly N and B, because here as we have only one B, so we can write here 1 because the number of blemished here are 1, okay. Similarly and B and, okay, here again 1 and B, okay. So what is this? Now we can see that here we have 2 blemished cars. Similarly here, now starting it like B and we have 1 B and B, we have 2 B's, and at the end what would we have? Let me check that how many combinations we have. So 1 2 3 4 5 6, okay. So let me have here as well 1, again B and here again 2, and the last one here would be B, and the value of x would be 3. Okay, so this is the solution of the question like this one, in which we have seen the number of the blemished cars as the random variable. Okay, and on the basis of it we have described the solution of our question. Okay, so this is basically the illustration of how to find out the random variables and how to miss out what is not available, and that is what the essence of the word random variables. Okay. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Question 3.3 of chapter number 3, which is related to the random variables and probability distributions, and the statement of it is, let W be a random variable giving the number of heads minus the number of tails in 3 tosses of a coin. Okay, so let me write here the given data. Okay, and in this given data we have a random variable W, which is what, which is the number of heads. So let me represent the number of heads with H, and okay, minus the number of tails. So let me write it with this tau n. So this is what, this is a random variable which basically shows the number of heads minus number of tails in 3 coin tosses. Okay, so how many coin tosses we have? We have 3 coin tosses. Okay, so this is the given data up till now. So list the elements of the sample space as for the 3 tosses of the coin, and to each sample point assign the value W of W. Okay, so what is W or omega? This is the value which corresponds with the values of this W. Okay, so this can be what, this W can have either 0 value, it can either have 1 value, okay, and it can also have 2 value as well, or any other values. We will see that. So this is what this W is. Basically these are the values which corresponds with the event which is here. Okay, so let me write all these values here in all 3 tosses. Okay, so let me write here in solution the tosses or the sample space. Okay, here we have to write the number of heads, here tails, and here W. Okay, so let me proceed with this. So let me have this table here. Okay, so the first toss here, which is, let me have here all the heads. So it would be heads, heads, heads in all 3 tosses. So here we can see that we have 3 heads, 0 tail. Okay, and W, we can see that this W corresponds with heads minus tails. So here we will have here 3. Okay, similarly heads, heads, tail. So now here we have 2 heads, 1 tail. So therefore 2 minus 1, which is W, and this would be 1. Okay. Similarly heads, tail, heads, again 2 heads, 1 tail, and here I will have 1 as well, and at the end heads, tail, tail. So here I have 1 heads, 2 tails, so therefore the value W would be minus 1, because 1 minus 2 is minus 1. Similarly now tail, heads, heads. Okay, so now we can see that we have 2 heads, 1 tail, so here I will have 1. Similarly tail, heads, tail. Okay, so now we have here 1 heads, 2 tails, so 1 minus 2 would be minus 1. Okay, similarly tail, tail, heads. Okay, now we have 1 heads, 2 tails, and the value of W would be 1 minus 2, so this would be minus 1, and the last one here would be tail, tail, tail. So 0 heads, okay, 3 tails, so 0 minus 3 would be minus 3. So let me see that how many combinations we have. So 1 2 3 4 5 6 7 8. Okay, so this is what, this is the sample space we have, and how many items would we have here. So let me again see the same box concept here. So we have 3 tosses, and in each toss we have 2 choices. We can either have heads, or tail, heads or tail, heads or tails. So it is here again. So 2 multiplied by 2 multiplied by 2 is 2 raised to power 3, which is 8, and that's why I have at the end counted the number of combinations here to check that whether all the combinations corresponds with the actual number of combinations, or did I miss any of the combination here. Okay, so that's why I have cross checked them. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.4 of chapter 3, and the statement it has is: a coin is flipped until 3 heads in succession occur. List only those elements of the sample space that required 6 or less tosses. Is this a discrete sample space? Explain. Okay. So basically we have here two parts of this question. In first part we have to show all the elements in which the 3 heads in succession occur, but there is a fundamental constraint that those tosses doesn't exceed 6 tosses. Okay, so therefore now let me solve it, and writing them all the solution, let me first have here all the tosses in which first 3 would become the head. So it would be head, heads and head. Okay, so this is the first possibility. There is also a second possibility that first we will get tail, then heads, and then heads, then heads. So this is again 4, which is less than 6. Okay, again there is a possibility that we would get first tails, then heads, heads and heads. Okay, so these are basically 5, in which we can see that here we have 3 tosses, which results in 3 successive heads. Okay, similarly we can also have here heads, tail, heads, heads and head. Okay, so there is another possibility. After it we can also have here tail, 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 and then after we can get heads, heads and heads. Okay, so therefore we have got here 6 tosses. Okay, similarly now we can have here heads, tail, tail, heads, heads, heads. Okay, similarly heads, heads and then tail. Okay, and then heads, heads and head. Okay, so these are now 6, and we have seen that we have reached to the limit where tosses can have. Okay, so these are the 6 tosses which are the maximum limits, and after it we will exceed the number of tosses. Okay, so these are all the possibilities or the sample space which we have here, and we can very easily see that these are all the discrete elements. Okay, we can see here that these discrete elements either can result in 3 tosses, here we have 4 tosses, here we have 5 tosses, similarly 6. So we can see that these are composed of the discrete values, and we cannot represent anything here with the numbers which are consist of the decimal point or anything just like this, or the fractions. Okay, so therefore this is basically the discrete event, or all the elements here are discrete in number. So we have here the discrete sample space, and that is for today, in which we have seen the solution of question 3.4, and I hope you have understood the essence of the questions like this one. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.5 of chapter 3, and the statement it has is determine the value of C. Okay, so we have to find the value of C so that each of the following functions can serve as a probability distribution of the discrete random variable x. Okay, so here we have part A and part B. Okay, and we have to solve them for certain values of x which are given here. Okay, these are the values or x-axis. So if you have a function here, let me have here the function f of x here. Okay, this is the probability distribution function, and here we will have x such that all the values of x would be here. Okay, so this will be 0, 1, 2, 3. Okay, so this is what, let me have this corresponds with the part A of this question. Okay, so before solving the questions like this one, let me tell you one thing here, one supposition and one thing which you must have here. Okay, so suppose we have here different probability density function. Okay, here, so if we have here one, let me use this color here. So if I have this one here, this here, this one here. Okay, so in order to have this, if this is A, the value of it is A here, the value of A, this is B here, and its value here is, let me have C. You must keep in your mind that the summation of A plus B plus B, all of this will give me this one. Okay, why? Because all of these are basically the probabilities. A, B, C, these three are the probabilities. That's why this is called a probability distribution, or PDF, or in some other ways this is also called probability mass function as well. This is probability mass function for the discrete random variables. Okay, and for the continuous one, this is called a probability density function, or PDF. So these are the terminologies we would have here, and in order to solve this thing here, I am going to give another example to you guys here. So let me have a coin, okay, which is tossed 2 times. Okay, so we have a coin which is tossed 2 times. Okay, so what are the possibilities in this coin? So either I will have here heads heads, or heads tail, or tail heads, or tail tail. Okay, so we have different possibilities here which are basically given here. Okay, so let me have here x, which is a random variable, and this x is, let me call it the number of heads. Okay, so in the number of heads, we can very clearly see here that the number of heads here are 2, the number of heads here are 1, here the number of heads is again 1, and here the number of heads is 0. Okay, we can clearly see here that in order to find the probabilities here, these are basically the numbers. Okay, so let me find the probabilities here as well. So how to find out the probabilities? So in order to find out this probability, first of all, I have to write the sample space. In sample space, I will have here heads heads, heads tail, tail heads, or tail tail. Okay, similarly, in terms of the probability distributions and random variables, the value of x will range from 0, 1, and 2. Okay, so here we can very clearly see that what is the probability of 0. So we can see that the 0 probability basically corresponds with this element where I have got 2 tails. So therefore the probability of the tail is how much? We can see that here the number of the elements in which only one tail occurs is here, and that is what the number of heads is 0, and this is the number of elements here in which this condition is satisfied. This is 1 divided by the total number of elements in the sample space, so this is 1 by 4. Okay, similarly, let me write here the probability of the heads equal to 1. How many numbers we have here, or how many items do we have here which satisfies the condition which is mentioned here? We have here 2. Okay, so this one and this one, and we can very clearly see that here we have the total number of elements in the sample space are 4. So therefore writing 2 divided by 4, I will have here 1 by 2. Okay, and similarly the probability of the heads equal to 2, again the number of elements which satisfy the condition in which heads is equal to 2, it is only 1, and then the total number of elements. So here I will get what? I will get 1 over 4. Okay, so in writing them all here, let me use this one for the problem which we are dealing now. Okay, let me remove it now, and then this is what? This is a random variable x, which is basically the number of heads. Okay, and this is, let me have here, this is f of x, which shows the number of heads. So I can have here the 0 number of heads. Okay, or I can also have 1 head or 2 heads. Okay. So let me draw them here. So for the probability distribution function here, how to draw it for the heads equal to 0, let me write the value here, and that value is basically here, and let me write it here, and this is here. Okay. This is 1/4. For the heads equal to 1, we have this function, and let me have here this 1/2, and writing it here, this would be here. And similarly for heads equal to 2, this is 2, and on the x-axis, we have this 2, and let me write its value here, and this is 1/4. Let me draw it here as well. Okay. So these are all the values which we had. Now this is 1/2, this is 1/4, this is 1/4. So in probability distribution, adding all these values, just we added them here, a plus b plus c. When I will add 1/4 plus 1/2 plus 1/4, which are the values, corresponds with the values 0, head, 1 head, and 2 head, and these are the values of the probability distribution function here. What I will get here, I will get here 1. Okay, so that is basically the essence of the questions like this one. In this question, I have told you the essence of the questions in this one, in which the cumulative probabilities in the probability distribution functions will ultimately give me what? Will ultimately give me 1, and this rule can be summarized with PDF underscore I from I equal to 1 up to infinity. Let me have, so it will give me 1, and that is the rule which we are going to follow in this question. Okay, so in this short discussion, I have told you how to tackle or target the questions like this one. If you have any question, you can ask me in the comment box. In our upcoming video, we will solve question 3.5 and afterwards. Thank you so much, and I will see you soon. Welcome back, guys. This is question 3.5, which we have discussed in our previous video, and I have explained that what will be the essence of the concepts which will be used here. Okay, so I have to determine the value of c so that each of the following functions can serve as a probability distribution of the discrete random variable x. Okay, so let me first solve part A of this question. And here the value of fx is what? This is c x square plus 4. Okay, for all the values which are given here. Okay, so what is basically this? So here let me connect this one with the previously illustrated concepts. Okay, so here I have f of x, and this is, let me have the values of x here, and all the values ranges from 0, 1, 2, 3. Okay, so what are these values? These are all the values which have been mentioned here. Okay, and this is what? This is f of x. So if I will draw something here, let me have some random distribution here, here and here. For all the values of this x, I have to see that all these values, this and this is a, b, c, d. Okay. So a plus b plus c plus d, this should give me 1, because this, in this way, this will be the probability distribution. Okay, so in order to do so, let me have here the formula, which is f of x equal to cx square plus 4. Okay, and all the values here ranges from 0 to 3. So therefore I have to write here what? I have to write here x equal to 0 up to x equal 3, and here this would be c x square plus 4. Okay, or let me expand it. What I will get here? I will get here c let me start it from 0, so it will be 0 square plus 4, okay, then plus c, and then I have to write x. After 0 I have to write here 1, so here it will be 1 square plus 4 plus c, here now 2 square plus 4, okay, and the last one here would be 3 square plus 4, okay, and this should be equal to 1. In order to satisfy that, it will be the probability distribution, and the same concept is illustrated here, what we have explained here. So let me expand it further. So by writing it here, I will get 4c here, 1 plus 5, this will be 5c, okay, here 2 to 4, 4 plus 4 8, here 8c plus, here it would be 9 plus 4 is 13, so here 13c would be equal to 1, okay. So now add them all together, so it will be 9 plus 18 is 8 is 17 plus 13 is 30, so here I will get 30c which is equal to 1, which will ultimately give me the value which is c equal to 1 by 30, and that is basically the solution of part A of my question. Okay? So this is the solution of part A. Let me expand it to the part B here. So let me first remove all these things. So in part B, the equation is just like here. Okay? This starts from 0 and ends up to 2. So let me solve it. In solving it, what I have to do here, it will be f of x is equal to c 2x, okay, and 3 minus x. So as it is starting from 0 and ending up to 2, and these values corresponds with this x, so therefore I have to write here x starts from 0 and ends at 2. Okay, so the same probability distribution, if I want to make it a probability distribution, what I have to do, I have to make this summation equal to 1. So this summation should be equal to 1, because now I am summing all these things, and previously I have told you that in probability distribution all the probabilities or the curves should end up in addition of 1. Okay, so let me expand it, and in expanding it, let me first take this c out. Okay, this c is now common in between all of them, so let me try it, and let me start it from 0, so it will be 2 0, okay, 3 minus 0 is 3, so it will be here. Okay, now similarly plus 2, now for 1 I will have here 1, and here 3 and choices are 3 minus 1, so 3 minus 1 is 2, okay, and plus, now here I have two choices, 2 and here 3 minus 2 is 1. Okay, so this and this must be equal to 1. Okay, so now let me solve it, and what I will get here, this 2 0 is how much, that is 2 factorial divided by 0 factorial, and similarly 2 minus 0 which is 2 factorial, because this is the formula for the combinations. Similarly, multiplying it with this one, so this would be 3 factorial divided by this 3 factorial, and then 3 minus 3 factorial, so it would be 0 factorial, and similarly here 2 factorial divided by this 1 factorial. Okay, and now 2 minus 1 is 1 factorial. I have been doing it because I know the formula for the A, choice B, and this is what this should be, A factorial divided by the B factorial whole divided by A minus B whole factorial. Okay, so I have been using this formula. Similarly here I have to use 3 factorial divided by the 2 factorial, and then 3 minus 2 is 1 factorial plus this 2 factorial divided by 2 factorial, multiplying it with the 0 factorial, because 2 minus 2 is 0, and here multiplying it with the 3 factorial divided by 1 factorial. 3 minus 1 is 2 factorial, okay, and this must give me 1 here. Okay, so now let me carry it out. So this will be cancelled out with this one, this will be here with this one, okay, this will be here with this one here, okay, and from it what I will get, let me do it here. So see, and here 0 factorial is 1, so here this all will give me 1 plus this is the 3 factorial. 3 factorial is 3 into 2, that is 6. 6 divided by 1 is 6. Okay, similarly here this is 3 factorial divided by 2 factorial, so 3 factorial is 6. 6 divided by 2 is again 3 multiplied by this 1, so here I will get 3 and this must be equal to 1, and ultimately it will give me 3 plus 1 plus 6, that is 10c, which is equal to 1, and ultimately the value of c will be 1 by 10, and that is the solution of part B of my question 3.5. okay, so I hope you have understood the essence of the probability distributions, that whatever the limit is, all the individual curves should give me what, or all the individual probabilities when summed together will give me 1. okay, so the same concept has been illustrated here, that when these are summed together it will give me 1, and that is what I have explained here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.6 of chapter 3, which is related to the random variables and probability distributions. And the statement it has is, the shelf life in days for bottles of a certain prescribed medicine is a random variable having the density function which is given here. okay, so this density function is basically equal to this value for all the values greater than 0 and 0 elsewhere. okay, so what do I have to find out here? Find the probability that a bottle of this medicine will have a shelf life of A at least 200 days and B anywhere from 80 to 120 days. okay, so in this question what we have to do here, we have this equation for all the values greater than 0, and what I have to do, I have to find the probability, and in order to find the probability of it, let me write this solution, and generically finding out the probabilities between two limits, as we can see here that it ranges from 0 to infinity. So what I can do here, I can just let me have this probability for let me have here x. okay. For it, what I can do, I can integrate it from 0 to infinity. okay, and here writing all these values, so this is 20,000 whole divided by x plus 100 whole cube. okay, so integrating it over all the limit, as we can see here that this is from 0 to infinity, so it will be equal to 1 here, because this is all the values of the ranges which are described here. But if you want to do it for any two ranges, let me describe them here as well. If you want to find the probability for the value of x which is greater or equal to A and less than or equal to B, so in this limit you have to write it from A to B, and this would be 20,000 divided by x plus 100 whole cube, and this should be what? This should be the formula which I am going to use here. okay, so this will be the formula which I'm going to use here. So therefore in part A the values are given here, and in this type of values what I have here, the value of A is, as we can see that this must be at least 200 days. So at least 200 days is 200, A is 200 and B is infinity, which can ranges from 200 to infinity. So let me write these values here. So when I will write these values here, so here it would be 200 and here infinity, so it would be 20,000 whole divided by x plus 100 whole cube and dx. Okay. So let me integrate it, and integrating it, this part, what I have to do, this is the constant part, so let me take it out, 20,000, and now integrating the values which are 200 to infinity, making this denominator the numerator. So with what I will get, x plus 100 and minus 3 dx. Okay, so now doing it, what will happen here in integration, I know the rule of integration, that if I have a value of x of n dx, so here in integrating it I will get here n plus 1 divided by n plus 1. So applying the same rule here with this with these ranges, what I will get here, I will get 20,000, okay, multiplying it with the x plus 100, and minus 3 plus 1 would be x plus 100, and minus 3, this would become minus 2, dividing it over this minus 2, and the ranges here are 200 to infinity. Okay, so now when I will solve it, then I will get here different values, and here let me first cancel it out, it will be 1, and here ultimately what values would I get, so let me write them here. I will get here minus 10,000 whole divided by x plus 100 whole square, and it ranges from 200 to infinity. Okay, so now let me write these values, and in writing these values I have to first put the higher limit. So when I will put this higher limit here, which is infinity, so anything divided by infinity would be 0, so here I will get minus 0. Okay, because 10,000 divided by infinity plus 100 would be infinity as well, so 10,000 divided by infinity is 0. Similarly here, subtracting it from the other limit, so there I will get, now putting the value of 200, so here minus 10,000 divided by this 200 plus 100, this would be 300, okay, whole square. Okay, so it will be just like here. Okay. So now solving it, what I will get here, ultimately I will get 1 by 9, which is what, which is the solution of part A of my question. Okay, we will very easily see that here, this is what, this is this calculation, minus minus will be plus, so plus will be this 0 will be subtracted from this one, so ultimately I will get this positive value. Okay, so that is basically the solution of part A. Similarly for part B, what do I have to do in part B? The only thing here I have to do here is that I have to change these limits. Okay, so in these limits, the lower limit would be 80 and the higher limit would be 120. So now let me change it. So the lower limit here would be 80, higher limit will be 120. Okay, so the final equation I will be having here would be this one, but the only thing here which will be changed here will be these two things. So let me change them here as well. So it will be from 80 to 120, and here what is this, this will be the solution. After solving it for the terms which I have done here for part A, you will get the answer which is related to this one. So this is the conceptual overview of finding the probabilities from the random variables or the density functions. If you have any question, you can ask me in the comment box. So see you soon. Welcome back guys, I hope all of you will be fine. So this is question 3.7, and the statement of it is the total number of hours measured in units of 100 hours that a family runs a vacuum cleaner over a period of 1 year is a continuous random variable x that has the density function. Okay, so once you are given that is random variable given is basically a continuous one, so you should keep in your mind that here you will have to use the integration. Okay, so that is the essence of the questions like this one. Okay, so if you have a question like this one, this is the probability density function, and this is fx, ranges from x in the range of x greater than 0 and less than 1. Similarly, 2 minus x for the x ranges from x is greater or equal to 1 and less than 2 and 0 elsewhere. So how to write it? Let me write it first. Okay, so here it will be f of x, and in terms of the integration, as all of these are basically the 100 r's, so therefore what I have to write here, I have to write from 0 to 1, it will be what? It will be x dx. Okay, plus from 1 to 2 it will be 2 minus x. Okay, from 1 to 2 it will be 2 minus x and dx. Okay, and elsewhere it is 0, so therefore no need to write here x. So what do we have to find out? Find the probability that over a period of 1 year a family runs their vacuum cleaner a less than 120 hours. Okay, so I have to solve it here, and here I have to write that the hours are less than 120. Okay, so as we can see here that all of these are in the units of 100, so therefore what I have to do, I have to divide these 120 hours over 100. So at the end what I will get, I will get here 1.2. okay, so less than 120 means from 0 to 120. okay, therefore here the range also lies between 0 to 1.2. okay, so now therefore integrating it over this period, so f such that x is less than 1.2 now, because this is in the range of the 100 hours, so therefore it would be from 0 to 1.2. okay, and in this range we can very clearly see that in this range we have all these ranges. This range also lies here because this is from 0 to 1, this lies here, and also this range from 1 to 1.2 because this is now from 1 to 2, so therefore I have to write it all. okay, so here it would be f of x here, or expanding it, what I will get here, I have to write it 0 to 1 x dx plus similarly from 1 to what? 1.2, because now I am not going beyond this 1.2 because all these r's are between 0 to 1, and here it will be 2 minus x dx. So now let me solve it, and integrating it, what I will get here, x square divided by 2 and here 0 1 plus here similarly these two are here, so here I will get 2x for this one. Now I am integrating them separately. 2 and x are separate, where 2 is the constant, x is the variable, so therefore integrating it with by using the rules of integration, here I will get it, and it will be from 1 to 1.2, and now minus x square divided by 2, and here it will be from 1 to 1.2. okay, so now these are all the ranges. Let me solve them here, and I can very clearly see that it will be 1 by 2, x square by 2 would be 1 square minus 0 square. okay, similarly here I will have 2x, so here 2 will be outside, and here I will have 1.2 minus 1 because this is now x, and similarly the last one here would be, this would be 1.2, and here x square, which is 1.2 square minus 1 square. okay, so now let me simplify it. It will be 1 by 2 plus this will be 2 multiplied by 1.2 minus 1 is, this would be 0.2, 0.2 multiplied by 2 is 0.4. okay, so and here this will be 1.2 square minus 1 square, so 1.2 square would be how much? Let me calculate it first. okay, so here it will be minus and here this would be 1 by 2 is 0.5. Here 1.2 whole square would be, let me write it here, it will be 1 by 2, and 1.2 whole square would be 1.44, similarly minus 1. Okay, now let me convert them here to decimals. So 0.5 plus 0.4. okay, and from it I have to subtract this 0.5 multiplied by 0.44. okay, so getting it, what I will get, let me find it out, this would be 0.22. okay, so it would be 0.22. okay, so now we have these values. Let me calculate them here, and what I will get, so it would be 0.68. okay, so that is the answer of part A which we have here. okay, so that is the solution of part A, in which we have found out the probability that the vacuum cleaner runs less than 120 hours. okay, so now let me proceed to part B. So in part B, we have to find the probability that the vacuum cleaner will run between 50 and 100 hours. So 50 to 100 hours. okay, again we have the scale in which we have 100 hours, so therefore dividing it over 100 here as well. So what I will get here, I will get from 0.5 to 1. okay, so this is the range of our equation now. So now we can see that this range basically lies in this area where this is only x. So therefore, in order to find it out, what I have to write, I have to find x such that it ranges in between 0.5 to 1. okay, so therefore it will be, the integration will be from 0 to 0.5 to 1, and this range is here, which is x, so it would be x dx. okay, now integrating it, what I will get, it will be x square divided by 2, and the integration of it would be in the range of 0.5 to 1. okay, so now let me find it out. This would be 1 by 2, and here it would be 1 square minus 0.5 square. okay, so let me solve it, and this would be 0.5 and this would be 1, and it would be 0.5 square is 0.25. okay, so ultimately it will be 0.5 multiplied by 0.75, which will give me the answer 0.375. okay, so what is this? This is the solution of part B of my question, which is basically given by this expression and also written here. So that's it for today, in which we have seen the solution of question 3.7. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.8, and the statement of it is, find the probability distribution of the random variable w in exercise 3.3, which I have also given here, assuming that the coin is biased so that a head is twice as likely to occur as a tail. okay, so let me first write the given data which has been mentioned here. So given data is the probability of heads is twice likely than that of tails, so therefore I have to make 3 slices of the total probability, and the 3 out of these 3 slices or the 3 parts, 2 will be given to the heads and only 1 would be to the tail. okay, so that would be 1 by 3, such that 2 by 3 plus 1 by 3 will be equal to 1. okay, which is basically the primary rule of the probability. So first of all, I have written it here, and this is the given data. Apart from it, let me recall the question 3.3, in which the w is a random variable giving the number of heads minus the number of tails in 3 tosses of a coin. okay, so we have 3 tosses of a coin, so let me write here the event first. Let me use another color here,
and this is here. So let me use here the event. Okay. In this event, the number of heads, the number of tails, and the w. Okay, what is w? This would be heads minus tail. Okay, so now after it, let me slice them here. Okay, will be like this one, and after it, I have solved it previously, but let me solve it again. So list the elements of the sample space as for the three tosses of the coin, and to each sample point assign a value omega of w. Okay, so what is the first event? First event, let me have here is heads, heads, heads. So number of heads here are 3, number of tails is 0, and h minus t, which is w, is 3. Okay, similarly, heads, heads, tail, we have 2 heads, 1 tail. Okay, so 2 minus 1 is 1. Similarly, heads, tail, heads, here we have again 2 heads, 1 tail, so 2 minus 1 is 1 again. Similarly, heads, tail, tail, so now I have 1 heads, okay, 2 tails, so 1 minus 2 is minus 1, which is this w. Okay, similarly, now tail, heads, heads. Okay, so now we have 2 heads, 1 tail, so 2 minus 1 is 1 again. So let me make it more. Okay, so tail, heads, tail, so again I have 1 head, 2 tails, so 1 minus 2 is minus 1. Okay, and now tail, tail, heads, so again 1 head, 2 tails, so 1 minus 2 is minus 1. Okay, and the last one here is we have tail, 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 so here we have 0 heads and 3 tails, so 0 minus 3 is minus 3. Okay, so these are the events, and with respect to those events, these are the events, and respect to those events we have the value of w, which is given here. So now, in order to do so, the sample space for this is the number of heads minus number of tails. So it would be what? It would be minus 3, minus 1, 1, and 3. Okay, so these are all the values which we have for the w in the event where a coin is tossed 3 times. Okay, so this is what the values of all these things. So now, in order to find the probability of these events, what do we have to do? We have to find the probability of w equal to minus 3. Okay, so in this event, what would happen in this event? What are the events which has been occurred here? So this is this one. Okay, this is the event where I have to find out the probability of tail, tail, tail. Okay, so this is what, this is the event which we have, and this is what, how many items do we have here of minus 3? There is only one item here, and similarly we can, as the 3 events are basically independent of each other, so therefore I can write here probability of t multiplied by the probability of t multiplied by the probability of t as well. Okay, so I know the probability of t which is given here, so let me write it here. So I have to write here 1 by 3 multiplied by 1 by 3 multiplied by 1 by 3, so it would be 1 over 27. Okay, so this is for w equal to minus 3. Okay, so this is for the first event. Now let me write it for the second one, which is probability of the w equal to minus 1. Okay, so what are those events in which w is equal to minus 1? These events are basically this one, and this one. Okay, so let me write their values. So this one, and this one, so let me write them here. So I have to find the probability of the heads tail, tail. Okay, similarly the probability of tail, heads, tail. Okay, and the last one here is probability of tail, tail, heads. Okay, so you can see that in all of these three events we have two tails while one heads. Okay, so let me move down somehow. So we can see here that here we have these events, and we can also write them here. Either I will have the event of heads, tail, tail, or I will have the event this one, which will give me -1, and wherever in probability I will get this or, I have to add them. Okay, so similarly probability of tail, heads, tail, I have to make them here as well. Okay, and or I can have here probability of tail, tail, heads. Okay, so this will be the third event. I know their values, so let me write them. Probability of heads multiplied by the probability of tail multiplied by the probability of tail here as well. Similarly, plus probability of the tail, probability of heads, and probability of tail. Okay, or the probability of the tail, probability of tail, and probability of heads. We have these events, and I can basically identify them here as well. This one is for this one, this one is for this one, and this one is for this one. So let me put their values, because the probability of heads, we have previously seen that the probability of heads is how much, that is here 2/3, and the probability of tails is 1/3. So let me write them here as well. So writing them here, probability of heads will be 2/3 multiplied by 1/3 multiplied by 1/3, plus probability of tail is 1/3 multiplied by probability of heads, which is 2/3, and multiplied by 1/3, and this one probability of tail is 1/3 multiplied by probability of tail, which is 1/3, and the last one is probability of head, which is 2/3. So let me calculate them. This would be 27. So 2/27 plus 2/27 plus 2/27. So ultimately what we will get, 6/27, which is also 2/9. Okay, so the probability of W equal to -1 is how much? That is 2/9. Okay, so now let's move on, and the probability of W equal to 1. Now let me find the probability of the W equal to 1, which is the event here, this one. Okay, so what are the events which have given me the probability W equal to 1? So this is this one, and this one as well. So let me write them here. So let me write them here, or start them here. So the probability of W equal to 1, so it would be the probability of the events which are head, heads, tail, heads, heads, tail, or heads, tail, heads, heads, tail, heads, and the third one is tail, heads, heads, tail, heads, heads. Okay, so we can see here that in all of these events we have what? We have two heads and one tail. Okay, so now writing them in the similar manner as we have done it for the W equal to -1. So what would we get here? We will have heads, heads, tail, or probability of heads, tail, heads, okay, or the probability of tail, heads, heads, okay. So these are the events which we have. Now separating them out, let me start it here and let me move down somehow. Okay, so it would be the probability of heads multiplied by the probability of tail, okay, or the probability of heads, probability of tail, and probability of heads, okay, and the last one is probability of tail, probability of heads, and the probability of heads as well. So let me mention them here as well. So this one here, okay, these three are for this one. For this one we have these three, okay, and for it I have this one. So again, let me put the values of the probabilities. So the probability of heads is 2 by 3. Similarly, 2 by 3 multiplied by 1 by 3 for the probability of tail. Similarly, probability of heads 2 by 3. This is 1 by 3, and here 2 by 3. Okay. Here we have 1 by 3 multiplied by 2 by 3 multiplied by 2 by 3 here as well. So let me calculate them, and here we would get 27. So 4 by 27 plus 4 by 27 plus 4 by 27. So ultimately I will get here 12 by 27, which is how much? We will have here 4 by 9. Yes, so 3 4 12 3 9 27. So this is for what? This is for the probability that heads is, sorry, W is 1. Okay. So the last one here is to find the probability that W is 3. Okay, and this is the only one where we had 3 heads. Okay, so heads, 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 and you can also see that in this table we have seen that this is the only one where the probability of it is 3. Okay, so now in order to do so I am going to solve it. So solving it by using the same procedure, as we have only one event here, so it would be the probability of heads, as the 3 events are independent of each other, so I am multiplying them together, probability of heads and the probability of heads. Okay, so as their probabilities are already given, so it would be 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3. So we will have here 8 divided by 27. Okay, so this is what, this is the given probability for heads equal to 3. Okay, so on the basis of it we have calculated some probabilities, so let me write them here. Okay, so let me write them here, and here let me use here the values of W and the corresponding values of the W. Okay, so we have the values of W. We start from -3, then -1, then 1, and then 3. Okay, we have also calculated their probabilities as well, so let me write them here. The probability of -3, how much is this? Let me see. Probability of -3, and this one was 1 by 27. Okay, so 1 by 27. The probability of -1, how much is this? So this was 6 by 20. Let me write 6 by 27. So ultimately I will show you that the addition of all of them is equal to 1. So let me write 6 by 27. So 6 divided by 27, probability of W equal to 1. So it would be 12 divided by 27. Okay, and the probability of W equal to 3, that is 8 divided by 27. Okay, so now adding them all together, 1 by 27, 6 by 27, 12 by 27 and 8 by 27, you will see that all of them basically gives me what they gives me 1. So this is the basic condition for the probability distribution which we have. Okay, so that's it for today, in which we have seen the solution of question 3.8, which was related to question 3.3, which we have previously seen. So if you have any question, you can ask me in the comment box. Till then, take care of yourself and I will see you soon. Welcome back, guys. This is question 3.9. The statement of it is: the proportion of people who respond to a certain mail order solicitation is a continuous random variable x that has the density function fx, which is 2x plus 2 divided by 5 for the range of x greater than 0 and less than 1, and it is 0 elsewhere. Okay, so there are two parts of it which is asking us to find something. So in first of it, show that probability of x greater than 0 and less than 1 is equal to 1. Okay, so let me first solve it. So let me first solve a solution, and this is the solution of part A, and we have to find the probability of it in the range which is given. So therefore the probability of x greater than 0 and less than 1, okay, we have to integrate the function f of x in the range of 0 to 1, and here we have to write 2x plus 2 whole divided by 5 dx. Okay, so let me solve it, and in solving it I will see that here these two are constant, so 2 by 5 will be here, and this x plus 2 has the power of 1, so therefore this would be x plus 2 whole square and whole divided by 2. Okay, this is the integration formula, that if we have some power and integrating it, the power will be added by 1 and similar powers will be in the denominator of it. Similarly, in the ranges of it, we have here from 0 to 1. Okay, so now this is what we have. In order to find the other things we have here, so this would be 2 will be cancelled out with it, so it will be 1 by 5, and in writing ranges, let me first start with the highest range, so it would be 1 plus 2 whole square minus 0 plus 2 whole square. Okay, so it would be 1 plus 3, which is 1 by 5, and 1 plus 3, which is 9, minus this is 2 to 4. Okay, so here we will have this one, and 1 by 5, 9 minus 1 is 5, so these two will cancel out, and at the end we will get 1, which is the required result we wanted to find out. Okay, so hence it is proved that probability that it ranges from 0 to 1 is equal to 1. Okay, so now similarly moving towards part B here, what is the statement? So find the probability that more than 1 by 4 but fewer than 1 by 2. So which means that this is the lower limit while this one is the higher limit of the people contacted will respond to this type of solicitation. So here I have to find out the probability of x greater than 1 by 4 but less than 1 by 2. Okay, so I have to integrate this one from 1 by 4 to 1 by 2, and it would be this f of x which was previously here, and this f of x is how much? This is basically we have here. Okay, so we have already found it out, just we have to change the limits. So here it would be 2 by 5, and here x plus 2 whole square divided by 2, this was cancelled out, and similarly now finding the 1 by 5, sorry, the limits here were 1 by 4 to 1 by 2. Okay, now solving it in such a way that limits have been put here, so it would be 1 by 2 plus 2 whole square minus 1 by 4, which is the value of x, lower value, plus 2 whole square. Okay, so you can find it out, and ultimately you will see the answer of it, which is 19 by 80. Okay, so which is what? Which is the answer of part B. So I think that's enough for today, in which we have seen the solution of two parts of question 3.9. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 3.10. Find a formula for the probability distribution of the random variable x representing the outcome when a single die is rolled once. Okay, so in a single die, what are basically the contents of the sample space? So let me first write the sample space, and a single die, what I can get? I can either get 1, 2, 3, 4, 5 or 6. Okay, so any one of them I can get. So in writing probabilities of each, so let me write the probability that I get 1. How much would it be? It would be the number of elements here and the total number of items in the sample space. So the number of element here equally divided, and these are 1, and the total number of items we have here are 6. Okay, so it would be 6. Similarly for 2, we will have, how many 2's do we have here? Only 1, because it can only occur once. So therefore the number of items here in the event when we will get 2 is basically 1 divided by the total number of items here. So the total number of items are again 6, so it would be 1 by 6. Similarly, the probability that we would get 3, it would again be 1 by 6. Okay, similarly for probability that we would get 4, it would again be 1 by 6. For 5, again we will have here 1 by 6, and for the last one, which is the outcome equal to 6, that would be 6 again, 1 by 6. So what is this? The probability distribution is uniform, and in plotting it, if I want to plot it, so let me have here, these are basically the outcomes, probability of the outcomes, and here we have the outcomes. Okay, so let me write them. If this is 0, we will have here 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. Okay, so let me have here this 1 by 6. Okay, so each and every item here has the same probability, and that is what? That is 1 by 6, 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 and 1 by 6. Okay, which means that all items here are equiprobable, and therefore this type of distribution is also called the uniform distribution. Okay, you can see that the distribution or the probability of all the items here are equal, so therefore this is the uniform distribution. Okay, so that's what we have solved this question for, and that's it for today. If you have any question regarding the events of these type of questions, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is chapter 3, which is related to the random variables and probability distributions, and today we are going to solve question 3.11. Okay, so the statement of this question is a shipment of 7 television sets. Okay, so let me underline the figures here. Okay, so 7 television sets contain 2 defective sets. Okay, so let me write here the given data, and for given data let me choose the color which is blue. So given data here. Okay, so in total of 7 televisions we have 2 defective sets. Okay, a hotel makes a random purchase of 3 of the sets. Okay, so out of these 7 a hotel does what? Out of these 7 a hotel basically select 3 random purchases. Okay, so this is the graphical illustration which I have been telling you. Okay, so if X is the number of defective sets purchased by the hotel, okay, so out of these three there can be X defective items as told by us, and find the probability distribution of X, which is what here this small x is a member of this capital X, which is basically the random variable, and I have to express the results graphically as a probability histogram. Okay, so I have to express this one. So now in order to solve it, let me solve it, and let me use this black color. So let me solve it, and here in order to solve it, I know the basic formula of the finding the probability of the event, and that is basically the probability of, let me have here, probability of X is what? This is the number of elements or choices in event. Okay, dividing it over the total number of choices. Okay, so this is the basic formula, but here in order to find the number of choices in an event, what do I have to do? Let me first underline it, and let me choose the color for it. Let me choose this green for it. Let me call this equation is equation A. Okay, so now in order to do so, we know that the number of elements or choices are how much. So let me see that what is this? This is basically the problem of a combinatorics. Okay, so here first of all let us see that here we have 2 defective items, and out of these 2 defective items how many choices will I have? I have basically the X number of choices which can be available in these 3 random choices. Okay, so this X can be either 0, X can be either 0 or 1 or 2, because it cannot exceed 2, because there are basically 2 defective items, but I have to select 3. So it can either be 0 defective item or 1 defective item or 2 defective item as a whole, but total number of items here we have are 2. Okay, when the X number of items are selected, so these would be the items which we have, so the number of items left will be the 3 minus X. Okay, so I will have 3 minus X of X items left here. Okay, and these choices are made for from how many choices which are not defective? So the non-defective items here are 7 minus 2 are 5. Okay, so I hope you have understood that these are basically the number of choices we have here. Let me repeat it again. These are basically the number of defective items, and out of these defective items I have to choose any X. Okay, and the value of X are basically lies from 0 to 2. Okay, similarly when any of the items are defected items are selected, the non-defective items left are basically 5, which are 7 minus 2. So out of those items I have to select 3 minus X. Why 3 minus X? Because the total number of items the hotel has to collect randomly are 3. Okay, so 3 minus X would be the remaining items, so therefore I have to make these choices. Okay, so these would be what? These would be the choices of the event. What are the basic total number of choices out of them? So here I have 7 items, and without any bias that either it will contain the defective items or not, these are basically the 3 items. Okay, so 7 choose
3 are basically the total number of what? These are basically the total number of choices. So therefore, I have to write it here. Okay. So I hope you have understood that what does it mean. So now in order to solve it, what do I have to do? I have to basically open it. So it would be 2 factorial divided by the 2 minus x factorial, okay, and so on. But before doing it, what I have to do, I have to keep here different values of x, because I know that either the defective items would be 0, no defective item out of in these three items. Similarly, it can either be 1 or it can either be 2. Okay, so let me take here the probability of x equal to 0. For x equal to 0, I have to put here 2 choose 0, okay, and here 5 choose 3. Okay, and similarly here it would be 7 choice 3. Okay, so these would be here. Similarly, let me move down somehow. Okay, so for the second item, when p x equal to 1, it would be 2 choice 1. Similarly, 5 choice 3 minus x is 2. Okay, and divided by 7 3. So this is what, this is the choice in which I have one defective item and two non-defective items. Okay, I have to solve it as well. And the third case is p x equal to 2, and here it would be what, 2 choice 2. Okay, and here 5 and 3 minus 2 is 1, so here it would be here, and here it would be 7 choice 3. Okay, so these are all the choices which we have. And now here what do we have? Here we have two defective items and one non-defective item. Okay, so when I solved it and I found it, here I got 2 by 7. Okay, you can try it. Okay, how can you try it? So let me first tell you that how can you do it. Let me do it for you. Okay, so when you will do it, you will do it like 2 factorial divided by 0 factorial and 2 minus 0 factorial. So it would be 2 factorial multiplied by here 5 factorial divided by 3 factorial, and 5 minus 3 is 2 factorial divided by the 7 factorial divided by 3 factorial, and 7 minus 3 is how much? That is 4 factorial. Finding it out, what I will get here, I will get, let me choose color which is green. So for it I will get 2 by 7. Okay, for this I have got 4 by 7, and for it I have got 1 by 7. Okay, so these are different values of the probabilities. Let me draw them graphically, because it is also told us to draw them graphically. So first of all, let me draw them here. Here these are the values of x, and here we have the value of f of x. Let me have them here, and here we would have, here let me draw them. Here we have different values for as 0, 1 and 2. Okay, so let me plot them or draw them here. So here for 0, the value of f of x is 2 by 7. For 1 I have 4 by 7, and here 1 by 7. Okay, and according to the probability distribution, I can also see that by adding 2 by 7 plus 4 by 7 plus 1 by 7, what I will get? Here I will get 1, which is the basic condition for the probability density function. Okay, I can also plot it. Let me plot it here as well. Okay, let me plot it, and this is x, and for x different values are here, and this is f of x. Okay, so we have here different values. Let me choose another color, which is this one. Okay, so for the first one I have, let me have here 2 by 7. So for 0 I have here 2 by 7. For 1 I have 4 by 7, and this is, let me have here 4 by 7. So it would be here. Okay, so this is 4 by 7, and the last one is 1 by 7. So let me have it here 1 by 7, and this is at 2. So here I will have 1 by 7. Okay, so what is this? This is the PDF plot
for our question which we have done here. Okay, so I hope you have understood all the underlying concepts which I have done here and what are basically the choices and how to find them out. So I hope it's enough for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is question 3.12 of chapter 3, which is related to the random variables and probability distributions. So before going to discuss the same problem, today we are going to discuss another very important topic which is related to the cumulative distribution functions. Okay, so let me write it here, and this one is also called CDF. Okay. So before discussing this CDF, we must have another function which is called PDF or probability density functions as well. Okay. So let us suppose a PDF in which we have a function like this one, in which the random variable is x and all the values of x are written here. So let me write them here as well, and these values are, let me write them here. This is 0, the value of x is 0, 1, 2 and 3. Okay, so let us have all these values, and such that the probability of x equal to 0 is, let me have it to a. Okay, similarly the probability value of x equal to 1 is, let me have equal to b. Okay, the probability of the x equal to 2 is, let me have it equal to c, and the probability at x equal to 3 is. Okay. So what is this? This is the probability distribution in which each instant here at the x-axis gives me the value of a random variable, while on the y-axis I have got the probability of the each of the instant v. So this is what the PDF we have. In order to convert it to the CDF or finding the CDF, what can we do? Let me have the same domains as we have here and here. In order to do so, this is x and here the values are, let me write them here as well. Okay, so these are different values here, and the value here is 0. Okay, so at 0, at 1, at 2 and at 3. So the same values here we have, and here in order to find the value at 0, we have here the value equal to a. So this value will proceed up till this 1, and here when it will reach 1, what will happen here? This a will be added with the probability which is at x equal to 1, and here we will get what? This probability will be here, and it will be what? It will be a plus. So this value is now a plus b unless and until it will reach this 2, and here this c, which is the probability at x equal to 2, will be added with it as well. Okay, so let me add it with it, and it will proceed up till this 3. Okay, so this probability value will be added, and here we will get a plus b plus c. Up till this 3, we will get the value at x equal to 3, and this will be added with this one as well, and here we will get this value because we don't have other random variables here, and this will be added here, and here this value will become what? Let me write it here. This will be a plus b plus c, and the probability of it is d. Okay, so as these are the total instances, so therefore it will be ultimately giving me equal to 1. Okay, so why this? Because the cumulative values of all these, because the values of all these in the PDF will give me a plus b plus c plus d. This is equal to 1, and this is the condition for the PDF, because all the probabilities here are equal to 1, and that's why this value will be here 1 as well. So that is about the CDF, which is the cumulative distribution function, because this distribution has been cumulated here in the form of this CDF. So where to use this? Okay, so let me have this color, and if I want to find out the probability of this region, okay, so this is what, this is the highlighted region, and this region here is the region between 2 and 3, and I want to find out the probability that x is greater or equal to 2 and less than or equal to. So do you have any knowledge that how to find out this area? This can be very easily found out by subtracting from this x equal to 2, this x equal to 2. Okay, from this x equal to 3 to this x equal to 2. Okay, so here I can find it out very easily by x equal to 3. Okay, and from it I have to subtract x equal to 2. Okay, so by using it I can find out this probability, and this will be the essence of our next question. Okay, so this is the question, and here I can find out different probabilities by using the same form. Similarly, if I want to find out other probabilities as well, just like this one, this is the highlighted area here, and how can we find it out? This is the region between 0 and 1. So here, in order to find the probability that x is greater or equal to 0 and less than or equal to 1, we can very easily find it out by subtracting the higher from higher value the lower value. Okay, the probability. So this is the introduction of the CDF, a formal introduction. If you have any question, you can ask me in the comment box. So let us discuss question 3.12 in our upcoming video. See you soon. Hello guys, I hope all of you will be fine. So this is question 3.12, and the statement of it is: an investment firm offers its customers municipal bonds that mature after varying numbers of years. Given that the cumulative distribution function which we have discussed in this lecture, what is cumulative distribution? So the number of years to maturity for a randomly selected bond is given by this f of t. There are different values, and these values correspond with this. They are given different values of f of t, and on the basis of t, on the basis of this f of t, what we have to find out, we have to find different quantities given in the form of part a, b. So let us solve it. Okay, and in solving it, let me have part a, and in part a I want to find out the probability at t equal to 5. What do we have to do? Previously we have seen that in order to find the probability of the instance between two events, let me have this one as 5 and this is the previous event 4. Okay, so in order to find the probability here, what can I do? I can subtract from this one. So therefore here, what we can do here, that we have this function. So therefore I have to find here f of 5, and from it I have to subtract f of. So let me see the value of f of 5. What is the value of f of 5? So from it I can very easily see that at this instant, let me change the color here. So this I can see that this one very clearly said greater or equal to 5. So therefore, taking the same instance here and writing here that by 4, and what is the probability at f4? Okay, here I can see that at this function instance, here the range of this 1 by 2 is from t greater or equal to 3 and less than 5. So in this instance 4 is already in it. Okay, therefore I am taking 1 as well. So it by 2 or 3 by 4, this 1 by 2 can also be written as 2 by 4. Subtracting for this one, what I will get here? I will get here 1 by 4 by using the LCM or whatsoever. So I'm not going to details of this. So this is what, this is the solution of part A. Similarly, in order to find the part B, what is part B? I want to find out the probability. So in order to do so, what I can do, I can see that in cumulative distribution function, in order to find the probabilities greater than 3, I have to take all the probabilities less than this and subtract it from 1. What I can do here, I can also write it here 1 minus f for probabilities of all which are is less than or equal. I hope you have got my point that why am I doing it, because in previous lecture you have seen that if different probability which are here. So in order to find the probability which is, if let me have this, so if I want to find the probability which is greater than this one, so for that I have to subtract from it all this area so that I will get. So in order to find the values here, what I can do here, that in CDF the less than or equal to values are almost similar. So therefore, in order to find the instance greater than this this one is all the values which are equal to what? These are all equal to b. Okay, so therefore I can also write here what it can also be written as 1 minus f equal to. So let me see the value it has here, and here by seeing it we can very easily see that this is 1 by 2, which lies in the range that t is greater or equal to 3. Okay, so this is the range which I want to find out, because I want to find out the value of f of t where the value of t is equal to 3. So therefore let me write their values. Okay, so it 1 minus 1 by 2, ultimately I will get what? So this is what, this is part B. In order to find the solution of part C, which is P 1.4, T is greater than 1.4 and less than 6. So here this one is very easy, and in order to do so we want to find out the probability that greater than 1.4 and less than 6. Let me write the formula for it, and for it I have to see two ranges in which this lies. So these ranges are 6 and 1.4. So it would be f of 6, the higher range, and from it I have to subtract 1.4. Okay, so let me write their values. What would be their values? So in writing f6, let me search for it, and here I can see that this basically lies in the range which is here. Okay, so this 3 by 4 lies in the range where t is greater or equal to 5 and less than 7. So 6 lies in the range here. So therefore it will be what? 3 by 4, which is here given, and similarly from it I have to subtract this 1.4, and let me see that where does it lie. So it can be very easily seen that it also lie here, because this is the range where t lies between 1 and 3. Okay, so this is 1 by 4. So this way 1 by 4, subtracting for it I will get 2 by 4, which is basically 1 by 2. So this is the answer of part C. Now in order to find the solution of part B, let me start it here, and that is probability that less than or equal to 5, given that greater or equal to, want to find out. So in order to do so I have to use the Bayes theorem. What is the Bayes theorem? I have to see these two ranges and divide it over the given range. So therefore it will become probability of t, which is greater or equal to 2 and less than or equal to 5, divided by the probability of this, which is the given value. So therefore the probability of t. So in order to do so, what would I do here in this range? What will I get? This will be the value of f at 5 minus probability or value of f at 2, and subtracting it from the value t is greater than 2, which I have mentioned in this question as well, that how to find it out. So it will be 1 minus f of 2. So let me put all these values here. So in putting all these values, f of 5, it lies in this range. So it will be 3 by 4, f of 2, which is here in this range, similarly dividing it over 1 minus f of 2. So f of 2 basically lies here. So it will be, so here I will get 3 by 4 minus 1 by 4. This will be 2 by 4. Dividing it over 3 by 4 will cancel out, and ultimately in this question what will I get? 2 by 3. Solution of part. Hello guys, I hope all of you will be fine. So this is question 3.13 of chapter 3, and the statement of it is the probability distribution of x, the number of imperfections per 10 meters of a synthetic fabric in continuous rolls of uniform width is given by this table. Okay, so here the values of x are given, and the corresponding values of the f of x are also written beneath these values. Okay, so what do we have to do? We have to construct the cumulative distribution functions of x. Okay, so in order to do so, let me write the solution of it. This is the solution, and let me choose this color black. In order to do so, let me have this graph. Okay, So this is the CDF graph, and in order to plot it and do it, first of all let me write all the values of x here or this x-axis. So this is 0, this is 1, this is 2, 3 and 4. Okay, these are all the values of x, and this is f of x. In order to find the values here, let me write all these values with this blue color. And for the 0, the value of fx is 0 0.41, and let me write it here. This is 0 0.41. Okay, and it will proceed unless and until we will reach this value 1. Okay, so when I will reach 1, what will happen? This value, which is 0 0.41, this will be added with the value at 1, which is 0 0.37. Okay, so let me add them together here, and here we will get 8, 7 and 0 0.78. Okay, so therefore it will become 0 0.78 here. Okay, and from here onwards up to this 2, it will be 0 0.78. Okay, so when it will reach this 2, the value at 2 is 0 0.16. Okay, so let me add with this 0 0.78 with this 0 0.16. Okay, so adding them together, what I will get? This is 4, this is 9, and here we will get 0 0.94. so let me have here 0 0.94. Okay, so at this 2, what will happen? It will jump to 0 0.94. Okay, so it is 0 0.94, and it will be 0 0.94 until and unless we will reach this this 3. Okay, the value of x equal to 3. Now we can also, let me also give them here. This is here, this is here. Okay, so when we will reach this 3, what will happen? The value at 3 is 0 0.05, 0 0.05. Let me add them together, and it will become 0 0.99. Okay, so here let me have here 0 0.99. Okay, so after it will be what it will be? Let me have here. Okay, it will be 0 0.99 until and unless we will reach this 4, and at 4 we can see that the value is 0 0.01. so when it will be added with this 0 0.99, what will we get? Here the value of it will become 1. Okay, so at the end we will get here this 1, and afterwards it will be here 1 as well. Okay, so what is this? This is basically the CDF plot, and basically this one is not small of f of x, but this is basically the capital F of x, because by convention f of x is basically the PDF, while capital of it, which is this one, this is the CDF. Okay, or cumulative distribution function. So now in order to write it mathematically, let me write here the value of x, and here we have different values. The first value it has is 0, which is for what? Which is for all the values which are less than 0. Okay, similarly we have here 0 0.41, for which values we can see that it ranges from 0 to 1, and all these values will range from x equal greater or equal to 0 and less than 1. Okay, unless and until it will reach this 1, the value of it will become 0 0.78, which I have told you that this is by adding them, and here this x will range from 1 greater or equal to 1 and less than 2, because here we can see that this is the range. Okay, now here after it we have got 0 0.94, and this ranges from 2 to 3. Okay, we can very easily see that this is the range. Okay, so now after it we have 0.99, because now here these two are added together, so 0.99 for x greater or equal to 3 and less than 4. Okay, this is the range. And afterwards, when it will reach this point, which is basically 1 here, and this will always be x is greater or equal to 4, and this is what we have. So now in order to write it, what we can do here, we can see that these are all the values which are for x, f of x. Okay, so these are all the values for f of x, and this is what, this is the CDF of the question we were asked. Okay, so that's enough for today, in which we have seen the cumulative distribution plot, okay, for the PDF which is given in the form of this table. So if you have any question, you can ask me in the comment box. So that's enough for today, and I will see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.14 of chapter 3, and the statement of it is: the waiting time in hours between successive speeders spotted by a radar unit is a continuous random variable with cumulative distribution function. Okay, so CDF for it is given in the form of this, in which this is 0 for all the values less than 0, and it is 1 minus x e to the power of minus 8x for all the values greater or equal to 0. Okay, so here what do we have to do? We have to find the probability of waiting less than 12 minutes between successive speeders. Okay, so this is now the solution, and here it has two parts. We have to find the probability of waiting less than 12 minutes by using the CDF and by using the PDF as well. Okay, so first of all, we have to see that here the data has been given. Here this is x, and x has been given in the form of this 12. Okay, this 12 is basically in the form of minutes, but here we have this distribution in the form of hours. Okay, so what do we have to do? I have to convert from this 12 minutes in the unit of hours. Okay, so therefore what do I have to do? I have to write this 12 and divide it over the total number of minutes in an hour. Okay, so by converting it, what will I get? Here 12 divided by 60 is 0.2 hours. Okay, so this is what we have found out. Now in order to solve it by using A, which is by using the CDF, what do I have to do? I have to write these values. Okay, and for writing them, what do I have to do? I have to find these values by using the f of x. So here we have to write the probability that x is less than 0.2. Okay, so when this is less than 0.2, it will be f of 0.2. Okay, so if this is here, this value which is x is greater than 0, so therefore just I have to pick this instance. Okay, and here I have to write the value of x, which is 0.2, so therefore it will be 1 minus exponential of minus 8 multiplied by 0.2. Okay, so here I will get 1 minus exponential of minus 1.6, and ultimately it will give me 0.7981, which is the solution of part A by using the CDF. Okay, so by using the CDF, what did I find out? I have found out the probability that the waiting time is less than 12 minutes between the successive speeders. Okay, now in order to do similar thing by using the PDF, which is the probability density function, here I have to do what? I have to write here the f of x. Okay, which is what here we are given the CDF, and in order to find the PDF from the CDF, what do I have to do? I have to find the derivative of this f of x, which is d f of x divided by d of x. Okay, so this will only range between these values because all others are zeros. So therefore when I will derive it, or I will find the derivative of this 1 minus e of 8 minus x, which is, let me write it here. So derivative of 1 minus exponential of minus 8x divided by dx. So here what will I get? I will get here minus 8 exponential of minus 8x. Okay, so this is what, this is the probability density function which we have here. Okay, so this is f of x. Now in order to find the values of it, what we have, what do I have to find out here? I have to find these values by integrating it from 0 to the range which is here 0.2 hours. Okay, because my ultimate goal is to find the same quantity by using the PDF in order to show that all these answers are similar but the methods are different. Okay, so therefore here I will have minus 8 exponential of minus 8x and here d of x. So here it will give me what? It will give me, sorry, here I have made a mistake because here when this will be 1 minus, so here it will be plus. Okay, so this is again plus, and here I will get 8, here it will be minus 8x dx. Okay, so now let me move down somehow. Okay, so now here the range is from 0 to 0.8. Now in order to do so, what do we have to do here? By integrating it and then finding the solution of it, what I will get? I will get here minus 8x divided by minus 8 multiplied by 8, and this range is from 0 to 0.2. Okay, here it is also 0.2, sorry, my bad. So these two will cancel out, and here I will have here minus exponential of minus 8x. It is from 0 to 0.2. Okay, so now finding these ranges by writing the highest range first and then this range, what I will get here? I will get minus exponential of minus 8 into 0.2. Okay, and then subtracting it from minus, and then minus exponential of minus 8 into 0. Okay, so here I will get minus exponential of minus 1.6, and then here this minus minus will become what? Plus. So plus 1, or it is 1 minus exponential of minus 1.6. Okay, we can see that these two quantities, which is here and which is here, these two are similar. Okay, so therefore the answers of it will also be similar, and it will be 0.7981. Okay, so the similar answer we have got from this question is what we have obtained from the CDF as well. Okay, so that is what, that is basically the solution of part B of our question. Okay, so that's it for today, in which we have seen the probability calculation by using the CDF and PDF as well. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is the exercise problem for the probability and statistics for engineers and scientists by Walpole, and this is chapter 3, exercise problem 3.15. Previously we have seen the CDF plot of the question 3.11. Today we have some questions, and on the basis of this CDF we have to answer those questions. Okay, so this is question 3.15, and here we have to find the cumulative distribution function of the random variable x representing the number of defective items in exercise 3.11, which is already found out in our previous video, which was related to the question 3.16. okay, also after it we have to find the value of px equal to 1 by using the f of x. Okay, so here let me have here the solution. This is basically the solution we have, and in solution we have here part A, and in part A I have probability of x equal to 1. Okay. So, previously we have seen that in probability of x equal to 1, that is basically the region which lies here. Okay. So, this is basically the region which is below it, and this is basically the value which I want to find out from it. So, that this value minus the value of this one will be the value which is here. Okay. So, I want to find out this value which is the probability at x equal to 1. Okay, because now this is a CDF plot, and in CDF plot all the things here are basically what? These are basically the cumulative. Okay. So, now in order to do so, we have to do what? Let me have it here. So, in order to do so, I have to write here the probability of x less than or equal to 1 minus the probability of x less than 0. Okay. So, we have to find it out. Now, in order to find it out, to find the values here, we have the value of probability here, and that is already given, which was the 6 by 7. Okay, which is the value at f x is equal to 1. Okay, this is 6 by 7. Similarly, the probability that x is less than 0, this is basically the probability of x equal to or 0. Okay, now putting their values, what I will get here, I will get 2 by 7, which is already given here. We can see that this is x is less than or equal to 1, this is given here, and probability x is less than 0, this is already given, and this is here. Okay, we can see that this is at x equal to 0. Okay, these are the values of f of x which are given. So, now finding them out, what I will get here, I will get 4 by 7, and that is the solution of part A. You should keep in your mind the difference between p of x and f of x. These are all the values of f of x. If you have seen it and you have been confusing it with these values, this is not basically the case, because all the values here it are basically capital F of x equal to 0. So, this is basically the value which basically lies here in this region. Okay, so you have to keep in your mind. Now, similarly, the solution of part B, and that is what the part B is here, probability that capital X is greater than 0 and less than or equal to 2. Okay, now we have defined two limits, and here in order to find the probability in these two regions, what do I have to do? I have to write the value of f, and that value is x is less than or equal to 2, which is the higher region, minus the probability of x f x is greater than 0. Okay, so we can see here very clearly that the probability that f x is equal to 2 is basically what? We can also write it like f of x equal to 2 and subtracting it from minus f of x equal to 0. These are also the t values. Now, writing them down, it is very clear that in this region this is 2 by 7, and in this region this is basically the equal region of 2. So, here it is 1. So, I have to write here 1, and here in this region I have 2 by 7. Okay, so it will be 2 by 7, and calculating it, what I will get here, I will get 5 by 7, which is basically the solution of part B which we have. Okay, so that is what, that is basically the solution of part A and part B of question 3.15. If you have any question, you can ask me in the comment box. See you soon.